Hi, I'm Dave Fornell, the editor of Imaging Technology News and Diagnostic and Interventional Cardiology magazine. I'm here at RSNA 2015, and I wanted to take you on a tour of some of the most innovative new technologies here on the show floor. Philips Healthcare earlier this year released what is known as app-based ultrasound. The Lumify system takes a transducer that can completely form the image and do all of the image processing and send it directly into an Android-based cell phone or tablet device. The system is able to then take the ultrasound images and upload it to a PACS or send it via email or a wireless device. The device is aimed at the point-of-care market. GE Healthcare a couple years ago released its vScan device, which has had more than 15,000 devices sold in the point-of-care market, used side by side with a stethoscope for triaging patients. Philips Healthcare has now entered with this device, which is expected to see large uptake because of its simplicity. The Lumify system works on subscription basis. The transducer is rented from Philips for about $200 a month, and the app is free. And when the transducer is no longer needed, you can send it back to Philips. GE Healthcare introduced ViosWorks for MRI cardiac exam acquisition. Cardiac MRI has traditionally been very complex, and this system is supposed to greatly simplify cardiac MRI exams. It helps with both the acquisition and the reconstruction of the MRAs. The software does 3D full chest volume scans and also includes time and flow information in an 8-minute scan. This includes both anatomy, function, and flow in a single free breath 8-minute exam. The FDA cleared the software, but it is not yet commercially available. GE Healthcare is billing this as 7D imaging because of the XY axis, flow, and time element information. Conventional MRI cardiac exams take about 70 minutes, and with the reduction down to about 10 minutes and the use of cloud computing, GE Healthcare is hoping that the uptake of cardiac MRI will increase in the United States. Currently it sits about 1% for cardiac MRI exams. Due to the volumetric information that's acquired in the MRI, traditional exams are usually about 200 megabytes, but because of the volumetric information in this type of exam, it's about 20 gigabytes. This has necessitated the use of cloud computing to help simplify the upload of information and to handle the large data set. At RSNA 2015, Toshiba introduced the industry's first dedicated MR sequence for lung imaging using its ultra-short echo times technology. This allows for imaging of tissue with very short relaxation times and high susceptibility regions as in the chest and lungs. The lungs are traditionally very difficult and not imaged on MRI because air has a very low signal.
What is showing here is the ultra-short sequence is showing the pathology and the comparison of the same patient with the CT.
Okay.
So as you can see the same pathological area and other areas like emphysema and some other pathology around on MR too. So you can see the same pathological area and definition of the pathological area as you can see on CT. Advantage here is that you are not using radiation.
There's one of the late breaker trials that they have today at RSNA is actually a gaming technology using the Microsoft Kinetic, where they have that set up in front of a DR plate in a room where they could actually track the motion of a patient. If they have an arm out of place or they're kind of sloping off to one side, it'll actually detect and give either a green light or a red light whether they could shoot it or not to try to cut down on the number of retakes. Earlier in 2015, EchoPixel received FDA 510K for its real 3D imaging system. The system can take 3D data sets and can project them in real true 3D using 3D glasses on a special screen. And the image data set can be manipulated using a stylus device to go both through the slices and also to rotate it in real time instead of using a mouse. The focus of the company currently is on structural heart and surgical planning. The system allows surgeons to have a real anatomical view in any axis and to be able to slice through tissue to see exactly what they're getting themselves into as they go into a procedure. The system has full PACS integration and offers visual cues that normally are not available on traditional 3D multiplanar viewing on a PACS system. Many of the things that are often interpreted as noise or artifact within an image, when you see it in true 3D and you could actually flip through the images, you could actually find that they're actually structures within the heart itself, or it is chordae tendineae that are coming in and out of plane. It's much easier to visualize these structures using true 3D and being able to rotate it on multiple axes at the same time. The EchoPixel system may be a key for the future in viewing PACS images. It offers the ability to rapidly go through images in a new way in visualization that radiologists are traditionally not used to seeing, and be able to increase the radiologist's workflow by cutting eye fatigue and also be able to see an additional number of exams. The ability to reduce fatigue is based on the idea that the radiologist will not have to reconstruct 3D images off multiplanar images in his head. The special glasses that are worn with the system allow you to actually look around the image as if you're looking around an actual three-dimensional object. And as you do that, it actually rotates the image around to meet the visual plane that you're looking at it in. The stylus that's provided with the system allows you to manipulate the image and turn it on any plane. It also allows you to go slice by slice through the data set as well to pull through the image. It's much easier to use and much more intuitive than using mouse clicks. Fujifilm Sonosite introduced its iVis handheld ultrasound systems at RSNA 2015. It's a point-of-care ultrasound system that can be handheld or can be set up on a desktop. The system enables 32 centimeters of penetration, has color Doppler, and there are several new apps that are in development for the system. The data that's collected from the device can be sent with both reporting and imaging information to either a cloud or it can be sent into an EMR. It has both front and rear facing cameras so that JPEG images can be sent for both telemedicine and for ER use. The device is Bluetooth enabled, so it may have future capabilities as a point of care device that goes beyond imaging for temperature, pulse oximetry, and other ancillary devices that can dump parameters and information directly into the patient medical record. The iVis system also has a Bluetooth-enabled 12-lead ECG system that can strap around the patient's chest and is extremely simplified. The system offers a full ECG report that can be downloaded into the electronic medical record. The device is designed to be very ergonomic, can be held with one hand very easily, and has thumb operation, so the other hand can be free to manipulate the transducer. At RSNA 2014, Toshiba released its SMI small vessel imaging for its Echo systems. And this year they released a 3D version of it for vessel imaging. This uses a freehand technique for organ perfusion and can image slower flow vessels and organs that are generally hard to image with Echo. The low flow is sometimes interpreted as noise and filtered out, but with the Toshiba SMI system, it processes the data into usable images. This expands the visualization of various velocities that otherwise are not available on ultrasound. The images could be acquired in a 3D data set and then rotated around for the full volume to see the flow within the vessels. One of the new additions to Philips angiography systems is patient skin dose. This is a radiation estimate on what the patient's skin dose is for the angiography procedure in progress. It shows a human figure and also a phantom cylinder showing the entry point and the peak skin dose on the patient from long procedures. This might be a reminder up on screens within a cath lab to remind the operators to move the C-arm so you do not burn the patient during long procedure times. One of the big concerns in the cath lab in the last couple of years has been staph radiation dose received from scatter radiation. All of the major vendors now offer Unifor's Dose Aware system, which is a staff badge that is worn and gives real-time feedback on radiation dose in the cath lab. Philips Healthcare has released a commercialized version of its Dose Aware Extend. This shows on the chart where each physician or staff member in the room is in relation to their dose that they're receiving from the X-ray. This case, with me in the blue, shows that my millisievert range is 16 to 18, whereas the people that are further back in the room have lower dosages. This is a constant reminder in the cath lab to have staff stay out of the radiation field to help lower dose. GE Healthcare introduced 3 new packages for visualization and enhancement in the cath lab. This software is available on the IGS 5, 6, and 7 series. One of those is the Vessel Assist. This allows for center lining that can go through CTOs or clots within the vasculature, and the center line can be used to better guide procedures through blocked vessels. This is an example of how the physician can mark the area that he wants to visualize with a center line on a CTA. And this is an example of how that center line will present within the cath lab overhead screen and can be used to help guide procedures to clear the vessel. This is an illustration of the center lines on the CTA that is now being overlaid on the fluoroscopy within the cath lab to help visualize the areas where there is no contrast infiltration.